Yeah, just wanted to say it's cool that we have a second talk kind of related to visual computing. It's also one of my favorite topics, and I think it goes well together. Creative coding, medical visualization. It's different, but it's kind of similar as well. And I really enjoyed the first talk of Lisa as well. Okay, so I want to present to you what we are doing with Rust for medical visualization. We basically started a few months ago working with Rust, so it will be more an experience report of what we learned and how we approached our journey into Rust. So I guess from all the technical details, I probably could learn even more from the audience, but still, yeah, I think there are some really interesting things we found out so far. Yeah, thanks for Katharina also for all the great work and the collaboration and the preparation for the presentation. We work for Daedalus. We are kind of the 3D visualization team at Daedalus Healthcare. And basically what I want to show you today is what we did achieve so far. No, what we want to achieve, what our goals are basically, what we did find out so far, and why we chose Rust, why we think Rust is great for our goals. So what do we want to achieve? This is our current desktop application, and it's showing the 3D volume visualization module. On the left-hand side, you see the actual volume rendering. On the right-hand side, this is the multi-planar reconstruction. So it's basically the 2D images, a 2D reconstruction of the orthogonal axis of the 3D volume. So how does the data look like? If you get a CAT scan or an MR scan in the hospital, the 2D slices, the images are taken, and the DICOM format, which is a popular or the main format for radiology image data, stores all the data in 2D images, and these can be reconstructed, can be visualized as a 3D volume, which is basically a stack of 2D images, and where each pixel is called a voxel. Yeah. And volume rendering works by shooting rays through every pixel of the screen through the 3D volume. So yeah, you can imagine it like this. You have like a virtual camera which goes through your screen plane, and then you check all the voxels along the ray, the intensity values, and this way you can create a 3D image from the 2D data initially. So we looked at our requirements, and the most important requirements were it should run we want to recreate this module, and the new module should not only run in the desktop but also in the web browser. It should be able to visualize the things on the GPU, but maybe in the future also with the CPU. And right now we are focusing on the client side, but maybe later we want also to move it to the server side as well. And yeah, I also wanted to mention why the web platform is interesting to us. So right now you need highly special to view the radiology data. You need highly specialized software, but we want to get away from that as well. There should be better access from departments outside of radiology, which does not have this specialized software. And also we want to support tablet devices because this way it is easier to show reports to patients. And probably sooner or later also access to medical data should be possible by the patients themselves over the web. So what did we find out? We decided to do a proof of concept, and we wanted to also look into alternatives than C++ because the obvious choice would have been recreating the 3D module with C++. We also wanted to check if all the critical requirements are technically supported by the technology stack we choose. And we wanted to get familiar with the technology stack. So we decided we want to do a basic visualization on the GPU. The most simple technique would be the multiplanar reconstruction because it's mainly 2D. But we also wanted to do get some experience for the performance of the technology. So that's why we decided the maximum intensity projection is often used for 3D visualization as well, but it can also be used for the 2D reconstructions where you just create one image out of multiple 2D slices. It's kind of a thick slice, so to say. And we also wanted to do some basic interaction so that you can get a feeling for how responsive it is. So, and there we decided to do just a simple scrolling through the 2D reconstruction. So basically we wanted to compare C++ with Rust. So we did 2 prototypes. And for each of them, we tried to also generate WebAssembly code. And in the desktop version, we use OpenGL for the visualization, and in the browser version, it should use WebGL for the visualization. So yeah, here you see the result of our basic C++ prototype. We didn't implement the scrolling there, but yeah, we used the AM scripting which is very popular for cross-compiling C++ to WebAssembly, and yeah, it worked quite well. We did the same thing in Rust. Was also a really good experience. And as you can see, we also implemented scrolling. And doing the same with for the desktop was also really easy. And yeah, in the end we decided that we skipped the desktop version for C++. It kind of took it was a little bit cumbersome getting all the Glue and STL and all the OpenGL libraries to work. But I mean, we kind of knew that it would work eventually, and so we decided we don't have to do it fully to the end. Yeah. So currently, what our future integration plans are for the module is we want to. Right now, we have the Java desktop application, which uses the C++ 3D module and is using DirectX underneath. It's integrated with GNI, that's Java native interface. And we add rapid behind the proxy or facade, because this way we can then, or we already started creating the Rust 3D module. And we basically use the same GNI interface so that the proxy can decide on demand, maybe feature by feature, if it should use the old or the current C++ module or the new 3D module, the new Rust 3D module. So we decided that the current GNI interface is kind of the rigid interface, and when we create a new one, we consider it more the flexible interface, because there were many choices made for the current module. Maybe not always the best ones, but we know that it's working well, and so we didn't want to make the same mistakes again. So we decided we will, for now, make a similar or equal interface, and maybe once we have everything in place, then we can consider also adapting the interface as well. And the new Rust module will then later also allow us to access it from the browser via the WebAssembly interface. And once all the features of the old module are also there in the new module, we can even consider removing the old module, or even the proxy and the facade if you don't need it anymore. Yeah, this is a pattern which is called Strangler Fig pattern. I really like this illustrative analogy. It's named after the strangler fig, which starts growing in the top of a tree and grows down and wraps the host tree until the host dies, and basically the tree will be made of the strangler fig eventually. So, and this running the old and the new module side by side until the feature parity is reached, there's a couple of advantages. First of all, it reduces the risk of a rewrite project, because when you start rewriting something from scratch, it might take a lot of time until you can actually replace it. And running it side by side allows you to early figure out if it works in a similar way, or if there are any problems, and you might even already ship it to a customer, or ideally you ship it to a customer as well. Yeah, as I mentioned, you can always compare it with the current production tested system. And it's sometimes easier than refactoring gradually, especially when you switch a language. Then it's probably the best choice, or a better choice. And this is a pattern created by Martin Fowler, invented by Martin Fowler. So yeah, I guess why we chose Rust is probably not so surprising for most of you, but maybe some of our participants have a similar choice and are interested what we found out. So C++ is a very established language and environment. That's certainly an advantage. But with Rust, the compile time is really short, which means less workflow interruptions. So you can more focus during the development and test cycle. You can focus more on the task at hand. it's also a lot easier using third-party libraries because you have a more modern packet management system. And yeah, in general, it's a very modern language and provides modern tooling. So the project setup was really easy, and it has a quite standardized project structure, which you don't have in C++. And the strong safety guarantees during our proof of concepts and our first developments of the new module, we never had to fight any null pointer issues except with the when we share the pointers over the GNI interface, then where you have to go to unsafe land. There you can still have the pain, but it was really, really rare. So within Rust, this is really great. And the platform interoperability, you would have it in C++ as well, but I think in Rust it's even better because all the crates by default ship with the source code. So yeah, in C++ you also have platform interoperability, but when you want to move to a new platform which you didn't support so far, then it can still be painful because maybe you don't have a library yet in binary form for this platform, and you have to figure out how to get it and how to link it and so on. So to sum up, Rust is really awesome, and that's why we decided we will build our new module in Rust. And I also wanted to share what we in the future think will be really nice, will work nice with Rust. One thing that we are looking at is SIMD instructions, SIMD instructions. So maybe if you never heard of it, if you have to process a lot of data and have to do the same operations on each item or each value over and over again, usually you have a for loop and each operation is processed sequentially. But with SIMD instructions, these are low-level processor instructions, it allows you to do the same instruction on 4 or 8 values at the same time. So this really can offer a great performance improvement. And yeah, as when you look at the cats there in the lower row, they are all moving at the same time. So this is of course much more efficient. And there is this feature is still highly experimental in the browsers, but there already is a portable SIMD project from Rust, which might come in handy in the future. Portable SIMD means that it's the SIMD instructions are usually different if you have an Intel CPU or ARM or AMD CPU. So usually it's not really portable, and it was always having a portable library where you write your SIMD code once and you can use it across operating systems and across different processor technology was always really difficult. So we are really looking forward to take advantage of this one. Yeah, I wanted to do a short recap why the performance requirements are high for us. So the volume can be really big. So each slice has often 512 by 512 pixels, and having 1,600 slices in a volume is not that big already, and this would be 800 megabytes in memory or on the GPU. Also, if you have a full screen rendering of a full HD resolution, it would mean you have to virtually shoot 2 million rays for each pixel. For each pixel one ray, and the diagonal of that volume is means that you have, in the worst case, 1,700 steps for each ray. And for interactive visualization, when you rotate the volume or zoom in and zoom out, you want to deliver interactive frame rate of 30 to 60 frames per second. So yeah, these are not yet the most extreme scenarios, but yeah, of course, there are some optimizations you can apply, but performance is really critical for our module. Also, what we are looking forward to is using WebGPU in the future. And there is already a great library developed by Mozilla, the VGPU-RS. And WebGPU offers a modern graphics API for the web, and is inspired by Vulkan, Metal, and DirectX. Just 1 or 2 weeks ago, the first public working draft came out, and it's already available via preview flags in the preview browsers. So it's also quite experimental so far, but there is a lot of things going on in this direction. And the community is growing, which verifies to us that Rust is definitely the right choice, and also many big players are actively supporting it. So our current and our next challenges, yeah, we restarted with production quality requirements. This meant for us to really get the Rust specific skills to mastery, which some things we could ignore quite well for the prototypes. And also the integration in the different application can sometimes be a challenge. And also static code analysis is something we are still developing. Rust Clippy is great. It offers a lot of value during development. And I just found out that there is already a community library for supporting Zona Source, which we use in many other projects as well. So we have a combined reporting for our static code analysis of our project as well. So before wrapping up, I also want to mention that we are hiring. So if you love Rust as much as we do and are interested in medical visualization, join us at Dedalus and support us in creating great software. And also working remote is definitely an option, as I do as well. As I mentioned, I'm based in Scharnstein, Austria, but our office is in Vienna. So I'm usually there for a couple of days per month. And here you also find our contact details if you want to reach out to me on Twitter or via email. Also to my awesome coworker, Katarina, who is not able to be here today. But also, took a great part in our preparing the presentation. Thank you very much. Now I'm looking forward to all the great questions.
Awesome, Harald. Thank you very much for the presentation. It was really interesting. Rust isn't it is an established language, but it isn't as classical established like C, C++. So it's always very interesting to hear real life stories and to hear established companies betting the farm on a programming language like that. I mean, it's a very important field that you are working in, and hearing that you are considering Rust, playing with Rust, and planning to use Rust is super interesting. Let me start with one question that follows up on your, I think it was the second last slide. You are hiring, you said. What is your experience in Austria? You are a company in Austria. You are offering Rust jobs. Is there already a market for Rust developers? Do you get a lot of resumes to take a look at? Is it hard to find experts in this area? Can you share your experience a little bit? I bet a lot of people in the audience are interested in, maybe they are looking for Rust people, or maybe they are offering Rust expertise to companies. So maybe you have some thoughts about that.
Yeah, I think the Rust community is not that big yet, but the cool thing is the candidates they're usually very excited and very motivated. So I really like that. And yeah, it's the first time we are looking for Rust engineers, and yeah, I think it's growing, and more people will join this technology.
Oh, interesting. Very interesting. We have one question from the audience, which has not yet been answered. Koshikim, I'm not sure how to pronounce the name. Maybe it's an abbreviation. He or she is interested in where to find additional information about compilation time, comparison between C++ and Rust. Do you have any numbers to share, or can you elaborate a little bit more about your experiences, the experiences of your team in terms of compilation time?
Unfortunately, I cannot share any numbers, but I think what I experienced is that incremental compilation is a lot better with Rust. Yeah, I think as far as I remember, C++ kind of has the problem that the header files need to be parsed. I think they block the language with improving the compilation time to some extent. I think there are some ways to work around it and so on, and there are some clever techniques that this is less of an issue, but I think C++ was not able to completely solve it. Maybe if the new C++ modules kind of reduces the pain to a smaller scope, but the pain is still there, I guess. And this is something I realized in Rust is really smooth.
Okay, thank you very much for this insight. It's, as I said, always interested to hear about Rust in practice. I currently don't see additional questions, so I have two questions left. They are more of the organizational part. Harald, I think you are already on our Discord server, right?
Yes.
Awesome. So if people have questions or would like to exchange experiences, they can get in contact with you via the Discord server. And I think if anybody is interested in working with your team, they can also approach you via the Discord server. And the second thing is, it would be awesome. I don't know if that's possible, if you would share the presentation with us. So if that's possible, it would be great if you could maybe share a link to the slides with the Discord, because you have awesome visual material in it. And if somebody is interested in that material or would like to convince his or her team to that Rust is really interested, then maybe your slides will be of great help.
Yeah, sure. I will get back to you right afterwards, and I will also turn on my Discord application right after this talk.
Okay, thank you very much, Harald. We really enjoyed having you here. Thank you for taking the time for doing this awesome presentation, and I wish you a good evening. Good evening to Scharnstein.
Thank you very much. Thanks a lot for building up this great community, and having such great talks at your meetup.
Thank you very much. Thank you, Harald.